viewers, once again, welcome to today's production. I thank you once again for your comments and contributions you guys have made for the past number of months. I know for the past few months now, I've been able to release a video because of that engagement. I'm going to look at a very important aspect which many are also asking for me to do. I'm going to talk about a practical aspect of how capacity free energy generator with multiple flywheel is made. That is how high capacity free energy generator with multiple flywheel is made. You know, there is the important role flywheel play in a free energy system, and that's what I'm going to show you today. I'm going to show you the importance of one of the production, which it will be of immense benefit. For instance, this is generator, and this is flywheel, and this is a joint system. Now, this flywheel, as you are aware, store kinetic energy, and is very important in the role concerning this generator. For the generator to produce a full capacity and stable electricity, the flywheel must be able to turn in a very stable way. Now let's see this production.
Small flywheel, large flywheel 400 kg. Motor.
This is electric motor, induction motor. Now you can see that it's turning based on the connection. This motor, induction motor, receive power from the generator that is there. The connection here is a joint, as you can see, is joint here, and this is flywheel, which is storing the energy. And you know that flywheel has the capacity to run in a very high speed. I cannot be stopped immediately. You can see now this is the speed ratio is increasing. You can see the joint here, as here, and this is another flywheel. All these are joined using bearings, and the bearings are here, are stored, are fixed here, and this is the generator. And the generator now, this cable of the generator is also interlinked to this induction motor, generator motor. So you can now see the ratio at which these two devices communicated. Now, if you want to have this high-speed generator, you must be able to have a generator, and this is the welding. This welding is high capacity welding. This also helps to run this. Now see it now. These machines are all run by the generator, and this welding, which is carried out now, is also carried out by the generator because the capacity production rate is very high. This is an industrial machine. It cannot be possible to run if this generator that is here is not high. To tell you, the flywheel contributed. Ordinarily, if this machine is on and the welding man is also working, then there is quite a reduction in the electricity aspect. So, but now, as you can see, there is no reduction. The welding is going on, and then this industrial machine is also on its own production, but still the voltage system is still very high. Now let's continue. It's still on. This is the cable, and the induction motor today is receive the voltage from, because one of this cable now is laid on this induction motor, so therefore it does not affect the motor. Now, I'm going to show you how this is possible. How can you produce this kind of system? How do you design it? How do you produce it? I'm going to explain how this can be done. Let's go ahead. Before I go ahead, a wheel that takes a lot of force to spin around. It might be a large diameter wheel with spools and a very heavy metal rim, or it could be a small diameter cylinder made of like a carbon fiber composite. Now, a flywheel needs a lot of force to start it off. Take a note of it. A flywheel needs a lot of force to start it off. So, if the flywheel does not receive a good energy, it cannot be able to start. So it needs a lot of effort to stop it. That is where the kinetic energy comes in here. When the flywheel is on a maximum speed, you can't just stop it like that. Even if you switch off the induction motor, the flywheel will still be on turn. Many of you have been in this position, you know what I'm talking about. If some of you are producing using flywheel, you understand what I'm talking about. When the flywheel is on a speed, you need a high force for you to stop it. Just the same way, before the flywheel can kickstart, you also need a very high voltage to kickstart. So these two things work together. It needs a very high voltage to start and also to stop. Take note of it. As a result, when it is spinning at a high speed, it tends to keep on, which means it can store a great deal of kinetic energy. Now, look at where some of you ask questions about flywheel. You say, how is free energy possible? Free energy is possible because of this flywheel. Apart from the way you can connect it to the induction motor, when the flywheel is on, a flywheel itself stores a great deal of kinetic energy. Now look at where movement, that is, it's not that you store the energy like electric or like voltage. No, it does not store the energy on voltage. Look at what I'm talking about. Maybe you see it now. Let me go back again here. Now if you observe now, see the energy stored now. See, this is the kinetic energy now. The energy is in form of what? Of movement. It's not that the energy is stored on inside the flywheel. No. What it means that even if you cut off or you disconnect this immediately, the flywheel can still be on turn, and that means that the generator can still be producing. So when the flywheel is on high speed as it is now, and you disconnect the electric motor, it does not affect the production rate of the generator because it already stored the movement. That's what I mean by store it now. Now, if you go back now to this aspect now you observe that it store the energy in form of movement, which is what kinetic energy, and energy in form of movement, not electric energy, but energy in form of movement. And the energy in form of movement is now helps to turn the generator, which we have seen there, to produce the light required. That is where the free energy make it possible, because many of you are asking, how is it possible for you to have a free energy? Where do you get your source of power, and what happens when it switch off? These are the things you want to know about this now. Now, there are different types of flywheel. Flywheel come in all shapes and sizes. Modern flywheels are a bit different from the ones that were popular during the Industrial Revolution. Instead of wide and heavy steel wheels with even heavier steel rims, 21st century flywheels tend to be more compact and made from carbon fibers or composite material, sometimes with steel rims, which work out perhaps a quarter as heavy. Now let's show you about what I mean by steel rims.
This is the steel rims. This is steel. Now if you want to compare this steel to this one now, to this one you see here, you know that this is heavier. This is heavier than what you see here. These steel rims here are lighter, just like using a bicycle wheel. You can use a bicycle wheel. Bicycle wheel is a steel rim, so it's lighter, but it's also moving the energy in a very high speed because it rotates. So this is what we're talking about here. This one you see here is an old flywheel system. Why what you see here, which is being used in this big generator, is a new flywheel system. Take note of the two. Now let me continue to what we say. Now, how do you know about a faulty flywheel system? Now there are different signs for you to know when a flywheel is faulty. One, you look at the bearing. This is the bearings. When the bearings crash, the flywheel cannot turn smoothly because most of the flywheels it fits on bearings. Just like what you see now here. There's a bearings here, and there's a rod that connects this flywheel through the bearings to this generator. That is why you see this thing. Wait, look at how it is now. Right, it is now. You can also see it here. This is a bearings, this is a bearings, and this is a rod that link these two. Now, if this is a flywheel now, so the flywheel is turns, but the bearings is also being holding it. That's where you see it. I say when the bearings scatter, then you see it now. Let's see. Look at what I'm talking about. I say a burnt smell. One of the signs of bad flywheel is a burning smell, like that of burnt toast from a bearing, which lead to scattering of the little round ions, which lead to these little ions are inside the bearings, because this is a bearings and the bearings has little ions inside. So when it scatter, that is where the flywheel is tend to be faulty. Now look at this area of production now, which is the main area. How do you form this system? How did you make the system? If you want to form the system at this now, how do you do it? First of all, you will need a setting. This is an iron. You can use a smaller iron. You must not necessarily be these big ions because of the cost. Because as one of my brother made me and was complaining of the cost of production. And I also advise most of my subscribers to go for less depend on your income ratio. Now this is a steel, because this steel is heavy steel, and this is generator alternator. As you see, it is a very big generator system, so it requires a very high capacity of motor. Now that is why you see this flywheel is heavy metal, and if you see that these ions that are linking them are heavy. So if you want to form scallops, you can use a lighter flywheel like a steel flywheel. You can also use a steel ions that link the flywheel to the generator, and you also have your bearings here. Sometimes if you don't have money to buy much bearings, you can just link the root. You can just link this place to this place, direct from here to this place, using one bearings. One bearing is okay. Or if it's a shorter generator, if it is short, it is not long, you can just link this to the motor and to the generator without the bearings, just to cut down the cost. And remember that this generator is a cable, and this cable of generator is a link. It has two, as you can see, it is two. One of them is being used by this boss for welding, and then another cable is being sent back to the electric motor to able to supply the electric motor with the current that is needed to enable the electric motor be spinning. So you should know that as big as the generator is being turned by the electric motor, the distance of the rotary motor, it does not matter as long as there is an flywheel and interlink between the rotary motor and the generator. So if you want to do this, buy this generator, get the generator, then get an iron and link them to the flywheel, either 22 flywheel, like 2 flywheel, and then link it to the motor and make it easier for you to connect. Now let's see the motor aspect.
Small flywheel.
Now this is the in between them. As you can see, this in between the 2 flywheels is a bearings. This is a bearing boss, and this is a bearing boss. So this one and this one are communicating using this bearing boss and this bearing boss. Now you can see there's a joint. This is a joint. This is joint, and this is because it's very, the distance is wide. That's why they put there's a joint here, and this joint is for you to for these 2 wheels to communicate. Now,
Large flywheel 400.
now you can see the next bearings here. This bearings is interlinked with the motor. Why this one? So if you can't to count the bearings, you can talk about having about 4 bearings here. 1, 2, and 3, and 4 that interlink this one because of the space ratio, and it's 2 flywheel. Now look at the motor. This induction motor is a very big one, as you can see. Why? Is because but it's still 2.something kW kilowatts. It's not about the size of the motor, but the speed ratio. I've said that earlier in one of my operations. I say it's not about the size, but the speed ratio. Now, if you observe this thing now, you observe that the motor is very big, and the motor link is linked from here to these bearings, and from these bearings to this flywheel, from this flywheel and this. So you can see the ratio now as which it moves. And this, you can buy the motor according to your size, and then you can also mount it the way it's been mounted like this. Now let's continue.
Motor. VFD.
Now observe something. As it is starting, you see it's starting on a slow motion. This is starting power is on a slow motion, it's not on a high motion. Now, but if as time goes on, you see that the speed ratio is increasing gradually based on the flywheel. Because why it's starting on the slow motion is because the flywheels are very heavy. Now, remember I said earlier that it takes force to start the flywheel that are heavy, and also take force to stop them. So that is the beauty of it. If the heavier the flywheel it is, the heavier for the motor to turn the flywheel in a very high speed for the beginning time, but also very difficult for you to stop it when it's on a high speed. And that is what makes the beauty of the kinetic energy. You can see now, as the generator is now on high speed, at this stage now, even if you disconnect this motor, the direction motor will take about few minutes to stop because it's already on high speed, and it will still be releasing current. As mean there's a disconnection of cable here now. This before it can be like 30 minutes time, or maybe say 10 or 20 minutes for you to stop automatically. And I will make this motor to supply voltage to make this generator to supply voltage to this motor very fast. That is one of the things you need to know. So when the flywheel is very high, is on a high speed, it adds beauty to the motor, to the generator and the motor. When that is, so you can see how high it is now. And that is why the welding here, which is taking place now, is using the full voltage. You can see this is the full voltage welding. It's not, and this industrial machines are also working. You can see now. The welding is in the high. The irons are well. It's not slow. You can see the smoke here, and you can see the industrial motor here. It shows everything there is perfectly well. So I want you to go ahead and do the operation by yourself, and don't forget to subscribe to the channel. It is a free channel, because I am going to show you more and greater things as long as a free is concerned. Thank you for watching, and thank you for your time.